Hello class, this is a continuation of calculating the area between two functions. In contrast, our previous example, we saw that we had to find the area from one point to another, so this area here, and then we had to add to that the area from the same point to the end point, and we had to add those two. In this example, we're going to find the area between the two functions if they're enclosed by the two different functions that we're working with. Areas enclosed by two functions, g of x and f of x, are calculated as a equals the integral from a to b of g of x dx minus the same interval of f of x dx. The reason for this is if we calculate the area of g of x, so this area here, so we're calculating this area, and then the area of f of x, we're calculating this area, this one here, and this one here. If we did the trapezium minus this area that's highlighted currently, we will be left with the area between them. Now, a rule in integration is if we have the same interval of two different functions and we have some operation between them, we can combine integration into just one integral. So if this was a minus, we minus them. If it were a plus, well then this would be a plus. And this is only the sum or difference of two integrals. Please take note that in this particular example, it must always be the case that g of x is greater than f of x along the interval a to b, meaning it's the top function or the top integral minus the bottom integral. So in this case, g of x must be on top minus f of x if it's on bottom. In this case, g of x, again, is on top. G of x is the parabola, minus f of x, which is always below along that interval. So let's get straight into an example here. So let's calculate the area enclosed by the functions g of x equals 2x plus 3 and f of x, x squared minus x minus 7. So the first thing we need to do is we need to figure out the interval we are calculating the area between. For this, we're looking for the points of intersection of both. Well, we can find that simply by letting these two equations equal each other. So x squared minus x minus 7 equals 2x plus 3. Solving this new problem, we will get x squared minus 3x minus 10 equals 0. Solving this by quadratic formula or whichever method you'd like, I'm getting a factor of plus 2 and x minus 5 equals 0. 2 take away 5 is negative 3. 2 times negative 5 is negative 10. So this factorization works. Skipping the solution, we get x equals negative 2 and x equals positive 5. So the interval we are integrating on is from negative 2 to 5. Now we must be mindful that g of x is always above f of x along the interval. So it's the line 2x plus 3, so let's now calculate the area. The area is equal to the integral from negative 2 to 5 of the line 2x plus 3 dx minus the integral of the parabola along the same interval, x squared minus x minus 7 dx. So I'm taking you through every single step. You'll see later on you can skip this part, but now we're going to combine the two on the same interval. Remember, this is only true if the interval you're working with is the exact same. Actually move this down to get some more space. So now it's going to be 2x plus 3 minus this entire function here. So x squared minus x minus 7 dx. 2, 5. Actually, let's now just combine the two. Negative x squared, 2x minus x, that's 2x plus x, so that becomes 3x. 3 minus 7 becomes plus 10 dx. So this problem that we had, which was very large, has now simplified down to a regular definite integral. So let's just evaluate this now. Increasing the power by 1, dividing by the new power. Don't forget the current coefficient that it has, plus, increase the power by 1, so it's going to become x squared, divide by the new power, not forgetting the current coefficient. With constants, you just plop on a variable to it along the interval, -2 to 5. Now, this is just a matter of substituting the values 5 first, so we're going to get -1/3 5 cubed plus 3 on 2 5 squared plus 10 times 5 minus the exact same thing, being lazy here now, thank goodness for the iPad, but instead of 5 we're substituting the values of -2. At this point it's just a matter of just putting all of this into the calculator. I'm going to use my physical one rather than the screen calculator. It's much easier doing this. So here we go. -1/3 bracket 5 cubed plus 3/2 bracket 5 squared plus 10 times 5. So I'm inputting this side first. Get 275 on 6 minus, and I'm just going to go through, so replace 5 with -2. And there we go. You should get -34 on 3. Evaluating this one last part, 275 on 6 minus 34 on 3. You should get 343 on 6. And because this is an area, if this was in centimeters, it'd be centimeters squared, but we don't know what it is, so we'll just put it as unit squared. And there you have it. That's how to calculate the area between two different functions. Hope to see you in the next example. Best of luck.